Alright, now we're going to have a little math education time, and this is one way you can gear up the lesson. So you can teach your students about a fixed point, which is any point that is not changed when you perform the rotation or the translation or the reflection. So when you perform a reflection, the fixed points are that line. They're the only thing that doesn't change. When you perform a translation, there are no fixed points because everything gets moved. And when you perform a rotation, the only fixed point is that center of rotation. And when you perform a transformation, another word for it is isometry, which this is another place you can gear up your lesson as far as group theory and all kinds of other advanced connections, but we're not going to go there. Alright, your isometry can be either direct or opposite. Direct means basically that the orientation stays the same, and opposite means that the orientation looks different. And you can combine these two characteristics and you'll end up with 4 isometries, and I've showed you 3 so far. When you have a direct transformation and fixed points, you get a rotation, and that's because the center is the only thing that's fixed, and you can look at the triangle and see that it hasn't been changed in any way, in the sense that it's still, the points are also oriented the same. If you have a direct transformation but no fixed points, this is a translation, because obviously none of the points stay the same, but the orientation is the same as you move the triangle along. If you have an opposite transformation and fixed points, this is a reflection, and it's opposite because all the points are kind of facing basically in the opposite direction that they were to begin with. And the fourth one, which is the new one, is if you have an opposite transformation and no fixed points, and this is what's called a glide reflection. And you can accomplish a glide reflection by translating and then reflecting, or reflecting and then translating. And I'm going to demonstrate that on the next page. And whichever one you do first, it doesn't matter. You'll get the same result. So first we're going to reflect, and I already have it set up. I can just push this little button. So first we're going to reflect our triangle across this line, and then we're going to glide it according to this vector right here. Alright, and so here's our final product right here, this green triangle. We reflected it, and then we translated it, or glide it. And now we're going to glide it and then reflect it and see that we get the same result. So if we glide our purple triangle first, we get this red one right here, and then if we reflect this red one across our segment, it goes on top of the original green one. So it doesn't matter what order you perform the glide reflection in, you'll get the same result each time. Alright, now we're going to see what happens when you combine isometries. This is the same as composing a function, and the goal is to see what you get after the end of your composition. So first we're going to start with a scaling triangle, and we're going to reflect it across line L, and then reflect it a second time across a parallel line M. So our first reflection gives us this green triangle, and then we're going to reflect the green triangle again over M, which is parallel to L. And we get this blue triangle. Now we want to look at our original triangle and our new triangle and try to figure out what isometry we have. As you can see, all the points are oriented in the same direction, so it's direct, but none of the points have stayed the same. So this leads us to a translation. And a side note, if you're curious about how to construct a parallel line, you can start out by constructing this line L, and then you can place a point anywhere you want, select it, select the original line, go up to the construct menu, and you've got this parallel line option. And as you can see, it created a line parallel to L through this point right here. Let's move on to our next combination. This time we want to reflect a triangle across one line and then across another line, but this time the line is going to be intersecting the original line rather than parallel. So if we reflect it across the first line, we get this blue triangle, and we want to reflect this blue triangle across this line right here. So we end up with this orange triangle. And now what we want to do is see what combination we've gotten. So as you can see, the points are still oriented in the same direction, but we've clearly moved the triangle. And if you can just imagine this pink triangle spinning around like that, you can see that we have a rotation. And the center of the rotation, which is the only point in the plane that hasn't changed, is going to be this point where the two lines intersect. And we can even test this by connecting a vertex on our original triangle with the center of rotation and then the vertex on the other triangle that matches it. And we can mark this as our angle by selecting the 3 points in order, going to transform mark angle, and then we want to just rotate this pink triangle by the marked angle, and as you can see, it went over top of the original triangle. Alright, let's move on to our next combination. This time we want to rotate something 180 degrees around a point P, and then rotate that another 180 degrees around a different point Q. So when we rotate the first triangle, we get this pink triangle as a result, and when we rotate that triangle, we get this yellow triangle. And looking at the original and the new triangle, it's pretty easy to see that all we did was just translate this triangle along a line. And again, we can test this by creating a vector. We want to mark it, and then we can select our triangle and translate. And all we need to do is just try to get the two triangles to match. Pretty close. So as you can see, rotating 182 times around two different points is the same as translating this triangle along this vector right here. Alright, and that concludes our lesson on geometric transformations using the Geometer Sketchpad. Like I said, you can take this either as complicated or as simple as you want it. There's a lot more that you can do. I've only shown you a little bit here, but hopefully now you understand how to transform triangles in Geometer Sketchpad. And don't forget to keep on innovating. And scan your computer for viruses on a regular basis.